Math 26, B. Okay. Oh, yeah, happy Friday, everybody. I hope you have a good weekend, and let's see. Getting ready for class. We're ready. So last time we did examples with discs, and then we did washers. And today we want to do integration by parts and partial fraction decomposition. So this is due next week on Thursday. I think that's the 21st. I need to write these down. The 22nd. Actually, no, it's the 21st. It's next week on Wednesday for a Monday, Wednesday, Friday. Yeah. Okay. So example 1. It's the integral of 4, let's see, integral of x with the power of 4, ln of x, dx. Okay. Let's take u and d. U is going to be equal to ln of x. dv is x to the 4th dx. On this side, it's the derivative, and that side, it's an integral. So the derivative will give us du equal to 1 over x dx. Over here, we have b equal to x to the 5th over 5. And then you multiply u with v, and then subtract the integral of v du. Okay. So that integral we had is equal to ln of x times x to the 5th over 5. Okay, subtract this integral of x to the 5th over 5 times 1 over x dx. So just a note that this x to the 5th is not going to go inside of the parentheses. ln of x is its own function, so it's probably going to look better this way. X to the 5th ln of x. And it's over 5. Okay. This is the integral of 1 over 5. Outside, and x to the 4th dx. So we'll add 1 to the power and then divide by that number. So x to the 5th over 5 multiplied by 1/5. So just this piece here, it'd be x to the 5th over 25. And we're done. Cool. I think that's, oh, plus c. You forgot that part. And now we're done. That's it. Okay, so we're going to do integral of e to the 3x times x squared dx. And let's actually do some scratch work on the side. So a small side problem. I did this something like this last class, but I want to walk through it one more time, and then I'll just mention it for the rest of the examples. But something like integral of e to the 3x. Use a u sub. Let u be 3x. du would be 3 dx. And so I've got dx over 3. So it'd be e to the u times 1/3 du. Okay, so 1/3 e to the u, and then put back what u was, which was 3x. Okay, so when we do this problem, we're going to have that shortcut. And we're going to use a table. So on this side are the u values, and this is my dv. You will start with x squared. dv is e to the 3x. This side, you take the derivative till you get to 0, and on this side, we're going to do an integral for each one of those. So the first derivative is 2x. Let me give us some more space. 2x. And then the derivative again is going to give me 2, and then one more time will be 0. This integral is 1/3 e to the 3x. do this integral again and get another 1/3 multiplied out front. So 1/9 e to the 3x. And one more integral of that is going to make this 1/27 e to the 3x. And then we multiply this with this. It's positive. The next one we subtract. So we have a plus sign. And this to this is going to be minus. Here to here is going to be plus again. All right, so the integral is equal to x squared times 1/3 e to the 3x. And then subtract 2x times 1/9 e to the 3x. And then add 2 times 1/27 e to the 3x. And add c. Okay, let me just check it out, make sure you got all the right stuff. This part. Yes. That part we add, and cool. Looks good. I think I will do one last step of writing this nice and easy to read, and then we'll move on. Okay, this is equal to x squared over 3 e to the 3x. Subtract 2/9 x, let's put 2x over 9, that looks a little better. Times e to the 3x. And then add 2/27 times e to the 3x. All right, another one by parts. Actually, I have a couple of these. I think I have maybe too many examples. So I guess we could always do more problems on Monday. So let's just work through them. So next we're doing cosine of x, ln of sine of x. U is going to be ln of sine of x. dv is cosine of x dx. This derivative will use a chain rule. So it's 1/sine x times the derivative of the inside. It's cosine. du equal to 1/sine x times cosine of x dx. And then this is an integral of cosine of x. So I have sine of x as my v. And then we're going to multiply across u with v, and then subtract this integral, du times v. this is equal to, I'm going to go over here. Ln of sine of x times the sine of x. So subtract the integral of ln of sine of x. No, we did that part. Okay, of sine of x times cosine of x over sine of x dx. I'm going to put it here. Sine of x and this cosine of x. So we're subtracting the integral of cosine of x dx. And like the other problem, this sine of x doesn't go into this parentheses. Like the parentheses trap that sine of x inside, and this one's just sitting there. So it would be better to just write it out to the front. Multiply it with the other function, which is x. Cosine x. Okay, so we have sine of x times ln of sine of x, subtract sine of x, and add c. So I got two more, and they're definite integrals, so we're going to evaluate them. It's the integral from 0 to 1. 0 to 1 of 2x squared e to the x dx. So what I'm going to do is find the indefinite integral, and then I'm going to come back later and put the ends. It's the so we're going to find integral of 2x squared e to the x dx. Okay, and then I just put a note to myself that we want to evaluate it at the end. So let's see, u equals 2x squared. dv is e to the x. This side's the derivative, that side's an integral. So here you have 4x dx. On this side, v is equal to e to the x. Multiply u with v, and then subtract the integral of v du. So it's just picking up from the integral that we had. 2x squared e to the x, subtract the integral of e to the x. So we're going to do this by parts again. And yeah, I think we could have used a table, but still, let's just do this again. So u is going to be 4x, dv is e to the x, dx. And this derivative will give you du equal to 4 dx. And that's v equal to e to the x. So we're going to subtract this whole piece where we multiply u with v and then subtract the integral of v du. 2x squared e to the x is the first term. Subtract 4x times e to the x. Minus this integral of 4 e to the x dx. Okay, then we have 2x squared e to the x minus 4x e to the x plus 4 e to the x plus c. Oh, actually, since we need to evaluate the integral, we're not going to put plus c. So let's write down the problem. It's from 0 to 1. The integral 0 to 1, 2x e to the x dx equals 2x squared e to the x. Well, all of this piece, but we're going to evaluate from 0 to 1. So first put in 1, and then subtract putting in 0. So 2 times 1 squared e to the power of 1. Minus 4 times 1 first. Add 4 times e to the first. Minus. Put in 0, so 2 times 0 squared e to the power 0. Subtract this 4 times 0 e to the 0. Add 4 e to the 0. Right, then this would be 1 right here. 2 times 1 times e is 2e. Minus 4e. Add 4e. Minus. Let's just keep these in parentheses. This first one's going to be 0. Also a 0 right there. Plus 4 times 1. So this is going to leave 2e minus 4. And I put that in a calculator, rounded it to 3 decimal places. So first I got 1.4366 and then round to 3 decimal places. Actually, yes. Like your homework. So it's 1.437. All right, one more like this. It's the integral from 0 to 1 x e to the x over 2 dx. U will equal x. dv is going to be e to the x over 2. Actually, yeah, e to the x over 2. And that's just going to be a u sub with u equal to x over 2. And what happens is you'll end up with a 2 multiplied by e to the x over 2. And over here, we wanted u to equal x. And take the derivative, du equal to dx. Cool. So we multiply u with v, subtract the integral of the phi du. And what we're doing right now is some scratch work. So this is going to be the indefinite integral first, and we'll evaluate later. Integral of x e to the x over 2 dx is x times 2 e to the x over 2 minus this integral of 2 e to the x over 2 dx. So we had 2x e to the x over 2 minus. So a u sub again, and you're going to get 2 multiplied with what's here. So 4 e to the power of x over 2. You would put plus c, and we can put plus c if you want, but now we want to evaluate the integral. Okay, so integral from 0 to 1 of x e to the x over 2 dx is this part, 2x e to the x over 2 minus 4e to the x over 2 that we evaluate from 0 to 1. So we put in x equals 1 and then subtract putting in x equal to 0, and then we'll simplify. So put in 1 for x. 2 times 1 e to the power of 1/2. Minus 4 e to the 1/2. Minus, put in 0, 2 times 0, e to the power of 0. You can put it over 2 if you want to. Minus 4 times e to 0 over 2. Okay. 2, let's write it as root e. Look kind of nice. Minus 4 root e. This is 0. And then we're going to add 4 times 1. So 2 root e minus 4 root e is going to leave negative 2 root e. And add 4. Then I put it into a calculator. I got 0.7026. We're going to round to 3 decimal places, so we'll round this up to 3. 0.703. Cool. 10 minutes. I think we're going to do more examples next week. Oof. And actually, they're about partial fraction decomposition, so each one takes some time. Can I do that in 10 minutes? Let's try one of them, and we'll do more on Monday. I'm going to do the integral of 4 over x squared minus 1 dx. So we're going to write fractions that we want to look like a over x plus 1, which by the way, this is 4 over a difference of squares, x plus 1 times x minus 1. Okay, so a over x plus 1, we need something like b over x minus 1. And I want this to be equal to 4 over x plus 1. Okay, multiply both sides by x plus 1 times x minus 1. A times x minus 1 add b times x plus 1 is equal to 4. And you can use any x values to find a and b. I'm going to pick x equal to 1 first. So that would be a times 0 plus b times 2 equal to 4. And you'll get b equal to 2. Next time, I think let's let x be -1. And then would have a times -2 plus b times 0 equal to 4. That's going to be 0. And a will equal -2. So that integral that we had was 4 over x squared minus 1 dx. We can write it as the integral of -2 over x plus 1. And 2 over x minus 1. So this is going to be -2 ln absolute value of x plus 1. Plus 2 ln absolute value x minus 1. Plus c. And we're good. Make sure that part. So I have like 1, 2, 3 more examples like this one, and we'll do them Monday. Let me know though over the weekend if you want more examples to get practice for the test. We can come back and practice next week. All right, have a good weekend, everybody.